All right, so this is our final talk of the evening. In case it wasn't incredibly obvious, this has been a lie. This is not Alex Russell or fake Alex Russell or anybody like that. Or maybe it is fake Alex Russell. Yeah, it is actually fake Alex Russell, so it isn't actually technically a lie. Pete's got a little wonderful announcement, hot on the heels of another announcement. This is our final talk. This is what some of us would like to call the pièce de résistance of JavaScript and JSConf. If Andrew Lunny would be a little bit quieter. Oh.
If that wasn't always the case.
Nice pants. Short it, short it, short it. So, is the projector working? It's not. Oh, no.
I can just actually give my talk in front of a blank screen because it's all in my head. Sorry about the technical difficulties. It must use Dojo back there in the back end. Which actually brings me to my announcement. I am, in case you do not know or are not aware of this, I am Peter Higgins, project lead of the Dojo Toolkit. Yeah, got mixed emotions on that one. And I actually inherited it from Alex Russell. Fake Alex Russell is Falix. He left, and I have since decided, kind of falling on the shirt tails of John leaving Mozilla. Everyone knows about that. John's left Mozilla for the Khan Academy. Yeah, good stuff. I'm actually taking over as project lead of the jQuery project. It's a very, very exciting time for all of us. I'm renaming the tagline to the Write More, Do Less library. And we're going with the synchronous module system. Yes. For Node. So this is actually, it was going to be I have a whole slide deck on my thoughts on the greatness that this transition will be, and just the whole common browser. I don't know if anybody was here for the Berlin talk that I did the same exact talk. It was ultimately the same exact talk in Berlin. The common browser JS and how we need to kind of unify and agree on a loader and agree on a micro framework that we can start from. Or, oh, you didn't laugh at that one. You guys really like the micro framework thing, don't you? Okay, that's good. That's good. I'm having, it's a tough crowd, Chris. Why can't I get my slides up? There's all sorts of funny shit in my slides.
Gonna need that back. Thanks.
Thank you for your time.
Hey, everybody. I'm the real Alex Russell. Get a lot of that. Awesome. So last year they had Chris, our inimitable organizer, had me follow Brendan, which was an incredibly tough act to follow. And many, including myself, will say I didn't actually live up to the task. So I think as penance, he decided to make me do it again this year to see if I could do better. And we'll find out. So something like 3-4 months ago, I started something of a blog fight about our favorite new demigod, feature detection, which we've sort of all taken as, on the client side anyway, the way to do it, right? You know, we want to build robust, sustainable web apps and JavaScript frameworks that are going to stand the test of time, that aren't going to be subject to significant drift as the browser population upgrades, as new things get introduced into the world. Like, we want the future to look different, so we want it to involve a lot of new and different user agents. We don't want to just have the same ones that we've always had. We want competition to work, and we want to be able to have the code that we write live inside that world the way everything else does. So I posited that you don't want to make Steve Souders mad. Steve's a really nice guy if you know him, but you don't really want to make him mad. And I sure don't, because I work with him, and he can actually walk over to my desk and sort of, like look very disappointed at me, and that's hard to take. Steve wrote last fall that the key to creating fast user experience in today's websites is to render pages as quickly as possible, and to achieve this, JavaScript loading and execution have to be deferred. Right? My bad paraphrase. But his point here is that in order to make anything fast on the web today, JavaScript winds up in the way, and it winds up in the way in a couple of different ways. So I tried to paint the picture for how we might get around this, right? How we might use some sort of a cache on the client side to help us determine whether or not we can do this. And I think my point was lost, because what I didn't discuss necessarily was enough of the ways that the core of the browser rendering pipeline makes life difficult if you're going to be relying on JavaScript for everything. This is a JavaScript conference, and for the second year in a row, I'm here to tell you to use a little bit less JavaScript in places where it might be problematic. So things that block suck, right? And those include, in a browser environment, DNS lookup, right? You can't go fetch any resource until you actually go figure out where you're going to go get it from. You can't necessarily do anything while JavaScript is parsing and compiling if you're actually counting on the result of that evaluation. Script downloads block rendering. Synchronous XHRs block everything, of course, and JavaScript execution, again, like synchronous XHR, blocks everything because there's the run to completion model of JavaScript in the browser. So this presents a series of challenges, and feature detection can really hurt you in a bunch of these places. So if you're building your application based on a tall stack of stuff that's going to have at the core of it, at the very front of it, some feature detection to add classes or to go set up the world for CSS or for other parts of your application to go start to play, you're putting JavaScript in the way in front of everything else. And this turns into a real problem, specifically when you're trying to get to a rich UI in a constrained environment. So let's talk about those constraints, because this is the new world, right? This is the new promised land. The mobile web is where it's at. And if you don't think that that's where it's at, then you're probably not paying close enough attention. So at the high end, we're getting significantly better hardware every day. The networks are getting somewhat better. But we're still limited, right? We've got single core as the top of the line right now. We're about to get dual core. We've got limited RAM, and it's shared RAM across everything in the system, right? It's significantly better than what I took to college with me, but and that's how old I am. But it's still not great, right? Compared to what you're doing on your desktop, where I just got like dual quad core Xeons with 16 gig of RAM the other day. Okay, that's pretty good, and it looks nothing like my phone. So the same sorts of techniques that we're using might have to adapt a little bit. So there's a lot more that's different, right? Some of these things are good, some of these things are bad. But effectively, if we think about the single-threaded rendering and execution model of the browser, none of these things do us a big favor when they're better, and a lot of them are worse when they're not. We don't have better speculative execution on top of ARM processors. The bus bandwidth is relatively lower. We're in a world of hurt. OK, I'm sorry. I can't do this anymore. This is really freaking boring. I can't. Yeah, so let's not talk about that. Let's talk about something much better. I want to apologize to everyone who came here to hear the feature detection talk. We can do that over beer later. But feature detection, like, just ask Steve what'll make your web app fast. He'll be happy to tell you. I don't need to do that for him. Don't make stuff slow. All right. But what I really want to talk about is JavaScript and how we can get to a place where when you write JavaScript in your application, it can sort of read like the way you wanted to say what you meant. The last several talks and a bunch of the stuff that's talked about new features for the language in the last couple of days have been incredibly inspiring about how we can move the language forward, about what sorts of things are coming in TC39, what sorts of things are coming at the behest of libraries. And you know me, right? Like the joke about the write more, do less library is not a so subtle dig at me, in part because I've attempted to work in this world to try to make libraries a way to get what we want, right? But they have these constraints put on them. So if your library happens to live, at the top level in a page, is it the thing that's blessed? The talk we had yesterday about scope object extensions was amazing because it set up this incredible narrative about the limited power of libraries to solve a lot of the questions that we've got. And it set up the language as the only place to necessarily solve the Tower of Babel problem. And this continues to this day. So I want to now bring out my good friend and colleague Peter Hallam to help fill us in on the rest of the stories and give you a sense for what it is that we're doing on the Chrome team to help you be able to say what you mean in JavaScript.
Thanks, Alex. Hey, everyone. All right. My name is Peter Hallam. I work at Google. A few months ago, Alex kind of put the word out that he was looking for people to help him with the future of JavaScript. And I'm a language guy. I spent 10 years at Microsoft working on C#. And when I heard that he was looking for someone to work on languages, that was an offer that I just could not refuse. So that sort of brings me here. It continually amazes me what people can do in the browser. It's not just little event handlers anymore. People are actually writing real applications. This is a favorite of mine, Pac-Man. Had a game of that last night at the arcade. As people are writing larger and larger applications, you're seeing all these libraries that are getting written to help people write these large applications. And over and over again, you're seeing that these libraries are solving the same kinds of problems. When we're talking about the future of JavaScript, this is kind of where we need to start for finding what we should be doing to the language. This is a quote by another famous language designer, Bjorn Strustrup. Language design is library design, and library design is language design. So everybody out there who's been working on your favorite JavaScript library, you've really been taking the first steps to basically designing the future of JavaScript. So I want to talk a little bit, I'm going to make this kind of short because we're going over time, but a little bit about just a couple of the things that we're thinking of in terms of the future of JavaScript. Obviously we're working together with the folks at Mozilla and everyone else in the JavaScript community to move the language forward. But specifically, we want to talk about writing large applications in JavaScript. So when you're talking about large applications in JavaScript, one of the differentiating factors between small apps and large apps is that you want to have components. And when we talk about components, what we really mean is reusable pieces of software, with strong boundaries that you can reuse. And one of the things there, one of the smallest sort of units of components in software is classes. Today in JavaScript, if you want to have a class, you obviously described as a constructor function, and really these two things together, both the constructor function and the prototype together, are the sort of reusable component. And yet it doesn't really look like that when you're writing your code. And of course you can use prototypal inheritance. This is how you do a derived class, which works great until your constructor function for your base class actually takes some parameters or uses some state or mutates some state, and then all of a sudden this really breaks down. But it does allow you to create an instance of an object. And so our new Pac-Man object is actually an instance of the base class actor. So the problem with, so the solution to that, of course, is to do something like this, which was actually lifted from one of the favorite libraries. Unfortunately, that actually does what you want, but it doesn't really read like Pac-Man, derives from actor. And we really want to try and change that. And of course, the library authors have already taken the first steps to trying to solve this problem. And so you see all the libraries doing that. So you see Closure library, I think that's Prototype, and of course base 2. Whoops. And so all these library authors have solved this problem, but they all solve it in a way that is not it's not composable, right? They're not compatible, so you can't take a class declared in one place and use it in another. And that's really I think one of the benefits for what we'd like to see is a syntax that actually describes and reads like what the intention that you want to express. Okay. Another big issue for components is modules, and Dave Herman did a great talk yesterday on modules and the benefits of modules. Again, this is something that all the library authors have solved. Whether it's Closure, whether it's Dojo, and again, once you put the syntax in the language, you get real reuse, and you don't have to opt into a single framework. You can actually use code from multiple frameworks once you have this. Again, this is another one where we had a great talk by Andrew DuPont on scoped object extensions. Again, it's a question of monkey patching is a place where you get friction with large application development. Once you, because all these shared objects are mutable, you can attach new things to new methods to them, which is great because it allows you to write code like this. But the problem with that is that once you get into large software development, these monkey patches can conflict. And so some libraries take great pains to not do any monkey patching at all. They provide the same functionality, but as you can see, it comes at a real syntactic cost. I think we'd all prefer to be able to write the first example rather than the second. But in today's JavaScript, that's prohibitive in large applications. So what we'd like to see is scoped object extensions, which is piggybacks off of Dave Herman's modules proposal. A scoped object extension is like a monkey patch. You declare it inside of a module, and it's available inside the module. But outside the module, it's as if it wasn't even there. And because we want reusability, we want to be able to import them across modules so that you can import these monkey patches into your own source code. Another one I think that we're going to talk about is asynchronous programming. This is another situation where which is a common programming pattern in JavaScript, which is the callback pattern. Because most JavaScript is embedded in single-threaded environments, we have the callback pattern. All long-running API calls take callbacks so that we don't ever block the main thread. The problem with this is that the callbacks infect your API, and they're really not composable because you have to pass these callbacks around everywhere. And so again, this is a situation where library authors have taken the lead, and to help alleviate this problem with the deferred pattern, some folks also call it promises. Basically, a deferred object or a deferred function represents a unit of computation that allows you to attach a callback to it once it completes. And so with deferreds, you see this, which moves the callback out of the parameter list of the animate function. But it's still really hard to see what animate is actually trying to do. And the reason why is that you've actually got to turn your code inside out into what's called a CPS transform, or a continuation passing transform. And it turns out that This is something that is actually really tough to do by hand, but is actually something that the compiler can automate for you. And so what we'd really like to be able to do is allow you to write code that instead of looking like this, looks a little bit more like this, where you've got, what you're really doing here is you're just iterating through a for loop, setting the margin on your element, and then saying, hey, I want to wait for 5 milliseconds before I go through this again. And of course, and this is the kind of code that we'd love to be able to see and be able to write in JavaScript. And the question is, so is that it? Answer is no. There's a whole lot of things that are in sort of that have been talked about in sort of JavaScript Next. These are, I think, most of the things that are have been talked about either in TC39. We've talked a lot about a lot of these today, and so we're hoping that you know there's a lot of things you can do to JavaScript to make it better. Again, we've talked about this. Brendan mentioned this issue of the when can we use this stuff, and sort of when can you try this out? And the short answer is we really want to be able to get feedback from library authors as soon as possible into the language design process, because at the end of the day, the language design only is successful if it lets you write code that you want to write. So what I'm going to do here is I'm going to come back to our deferred function example. 1 minute here. And so what we did is we actually wrote a compiler for most of these new features that translates it from the new feature syntax into standard browser JavaScript. And actually, this is where I want to do a shout out to some of the guys that helped, that wrote this. Other folks at Google, Chris Burrows, Martin Malley, John Messerly, Bob Nystrom, and of course someone you folks all know, Eric Arvidsson. And as you can see, the code that this compiler is translating this into is pretty wonky. You wouldn't actually want to write this stuff yourself, but at the end of the day, this is the kind of thing that callbacks actually forces you to do. Now, obviously, you're not a compiler, so you're not going to write it quite like this. But at the end of the day, this is the kind of thing that it forces you to do. And so we actually have this hooked up so you can run it inside the browser and get it working right now. And so what we really love is for everyone here to give this a try, give these new features a try, and give us feedback on whether this stuff is actually going to solve your problems. So what we've done, so Google is open sourcing Tracer, which is our in-browser JavaScript to JavaScript compiler that compiles from sort of JavaScript Next down to browser JavaScript. So we've just open sourced it on code.google.com, and the first short link is a REPL loop that you can use to actually try out this stuff in the browser right now. And the second link is a link that you can use to actually for the slides themselves, and you can actually see the compiler running in the talk. All right, I think that's it for me. Thanks, folks.
So yeah, we're really excited about Tracer, and we're hoping that you'll try it out and give us your feedback, especially about the new features. It can't implement everything, as we've mentioned, and we hope that you'll give it a shot, let us know how it goes, so that we can get what you think is good and bad fed back into the standards process. You can try it out today, give it a go, and questions? No questions about any of that, really? Come on. Okay, beer. All right, I get it.
All right.
Beer.
All right. Well, thanks.
Did you remember the baby?
Oh no.